Welcome back, Wolfpack. We are moving on to Module 5, which is triangle congruence. Today's essential question is how can congruency be determined for triangles, and if so, what properties about them can be concluded? And after today's lesson, I hope that you are able to prove two triangles to be congruent. So let's get started. Now imagine, for example, 1A, that there is a little question mark right there on that first triangle. But it says find the value of the variable that results in congruent triangles. Well, I noticed that this is 45 degrees, and this is 45 degrees, and this is 55 degrees, and this is 55 degrees. So we know that 180 degrees are in a triangle. So gotta love the bell. Okay, so honestly, we don't even really need to focus on what the question's asking us. We really just need to solve for x. Okay, we need to solve for x. So I know that all of the angles together add 180 degrees. So together they've already given me 100 degrees. So this angle has to be 80 degrees. But that's not what x is. So 5x plus 30 equals 80. 5x equals 50, x equals 10. Okay? So in this question, really, we're basically just solving for x, even though the question was worded slightly different. But down to example B, we're looking for the value of the variable that would result in congruent triangles. Okay? So I noticed that this side is 50 millimeters, and this side is 50 millimeters, and this side is 30 millimeters, and this side is 30 millimeters. So this side is 36 millimeters, but this one, it doesn't have it. So in order for it to be congruent, we need to set them up. In order to find the variable, I should say, we need to set them up to be congruent to each other. So 2y plus 20 equals 36. 2y equals 16. Y equals 8. Did I just do that correctly? I sure did. Good. Making sure. So when y is 8 degrees, or I should say degrees, but when y is 8, okay, when y is 8, then this piece is 36 millimeters, which then matches this side, which is also 36 millimeters. And then all of the triangles, I should say both of the triangles, are congruent. Again, all three sides of triangle 1 match all three sides of triangle 2, so therefore the triangles are congruent. Okay. So let's talk about some actual congruence theorems. And this is just the starter lesson. We're going to go over this a lot and do some activities with it, so don't worry. The ASA, triangle congruence, says if two angles and the included side of one triangle are congruent to two angles and the included side of another, then the triangles are congruent. And think about the word included meaning like middle. Okay? Middle. So two angles, angle, angle, and the included side, the side in the middle. So for example, angle A has one congruency mark, angle D has one, so A and D are congruent. Angle C has two congruency marks, so does angle F, so C is congruent to F. And AC has one congruency mark, DF has one congruency mark. And AC is the included angle. It's between the two congruent angles, and DF is the included angle. So this is an example of the ASA congruence. Okay, let's scroll down. SAS. What do you think SAS stands for? Well, it's side, angle, side. If two sides of the and the included angle of one triangle are congruent to two sides and the included angle of another, then the triangles are congruent. Here's an example. This side is congruent to that side. RT is congruent to UW. And then RS is congruent to UV. Well, the included angle, the angle between the two sides would be angle R and angle U. Are they congruent to each other? Yes, they are. So that's side, angle, side. Side, angle, side. One more. This one is the most, I should say it's the easiest one in my opinion, but yet it tends to trick students up for some reason. I'm honestly not sure. But this one is, what do you think the S is? Sides. If three sides of one triangle are congruent to three sides of another. Not that all of these three sides have to be congruent to each other, but each side of one is congruent to a corresponding side of another triangle. So BA, it's congruent to what corresponding side? SR. BC, it's congruent to what corresponding side? ST. And AC is congruent to RT. So all three of one are congruent to all three of another, so it's congruent by side, side, side. Let's put this in practice. Determine whether the triangles are congruent and explain our reasoning. Okay, so I see that we have 19 centimeters and 19 centimeters. And we have 20 centimeters and 20 centimeters. So I have two sides. Well, we learned side, angle, side. Okay, side, angle, side. Well, the included angle of this triangle is 43 degrees, and the included angle of this triangle is 45 degrees. There's no way I can prove, since those are not congruent, I cannot prove that congruent by side, angle, side. So let me go ahead and mark that again, my apologies. Okay, so 43 degrees is not equal to 45 degrees. Also, this side is 15 centimeters. I have no idea how much that one is. So I honestly cannot say. And I know it can't be, I mean, it could be 15, maybe, possibly, but we don't know for sure. So we cannot determine that these are congruent by the information that they give us. Okay. Look at example B. We have 61 degrees. Sorry, let me mark it congruent. That would be better. 61 degrees is congruent to 61 degrees. And 2.3 centimeters is congruent to 2.3 centimeters. Now, here's where it gets a little tricky. They gave us 45 degrees, but they didn't give us this angle. This would be the corresponding angle. We don't know. They didn't give us that one. However, we can solve it because we have the other two. So 74 degrees plus 61 degrees is 135. So we know that these two angles together are 135 degrees. Well, in a triangle, we have 180 degrees. So 180 minus 135 is 45. So by doing a little bit of math, I've learned that that angle has to be 45 degrees. So now I can actually say, wait a minute, this one's 45, this one's 45. So I have an angle congruent to an angle, a side congruent to a side, and an angle congruent to an angle. A, S, A. Angle, side, angle. So by that that triangle congruence theorem, yes, they are congruent. Okay, so you would actually say yes, A, S, A. Should put the word yes first. Okay, we are almost done. Here are a couple of examples. I'm going to do A and B with you. I'd love for you to try C through H on your own. So like 6 problems, and see how many of them you can get right before I go over them in class. Can the triangles be proven congruent with the information that's given in the diagram? If so, state the postulate or theorem you would use. Okay, so we see on this letter A, this side is congruent to this side is congruent to this side, but what about this side? Well, obviously, they share a side, and the side that they share is indeed congruent. So yes, these are congruent to each other, side, side, side. Okay? And also, we can see here, angle is congruent to angle, Angle is congruent to an angle, and they share a side. So angle, side, angle. Angle, side, angle. So the answer would be yes, because of ASA. So take a moment. I want you to try to do C through H on your own. There are some no's, there are some yeses, and we will go over them in class. Have a great day, and I apologize for the interruptions of the bells and stuff, but hopefully you were able to power through. See you next class, Wolfpack.